if you guys want to talk with your neighbors, for those first two examples, do you believe one, both, or any of them are functions? Do you like that stuff? So, this one over here on the left, function, function. All right, it's a function because it's linear, and you will notice I abbreviate function as FCN, just because I'm lazy. And the reason it's function because it's linear. All right, what about this one over here on the right? Is that one a function? So that's a circle. Okay, x squared plus y squared equals 9 is actually the equation of a circle. All right, and if I graph a circle, for that, do I have, for one x, only one y? So if I'm looking at this x over here, I have two different y values that attach to it. So this one is not a function. We have a couple of different ways that we can go through and tell whether or not something is a function. If it's a graph, you can use the vertical line test. If it's an equation, you're always going to want to look for a y squared term. And then if it's a relation or a table of data, that you're going to look for the same x with two different y values. Can I scroll a little bit? At least move this so it's up at the top. You guys want to try the first part of that example on your own? Ready for that yet? Not quite. Are you a little mushy? And if you guys want a calculator, they're at the back of the room. You guys can use Calculate E4 on your phones. Whatever is easiest. And I've almost got the entire section of the book ready. Did you guys get through for that first one? All right, cool. Now, what are you thinking for this second one over here? Top right, negative aspect.
Or just like of everything, what's positive and negative, positive.
Pretty much. So what we're doing is we're multiplying the entire equation by negative. So exactly what you're saying. Switch all of your signs. So it's going to be negative 2x squared plus 5x. What are we thinking for our next two? How about this one over here, lower left? F with negative x. What if we do when it was f of 3? Plug it. This one you're doing the same thing. It's plugging in a negative x every time you see x. So it's going to be 2 negative x quantity squared minus 5 times the negative x. Now that negative x when it's squared is a positive, so I still got positive 2x squared, but negative times negative over here, this one turns into positive 5x. And then what are we thinking for lower right-hand corner? Yeah, we're just distributing. Multiply each of those individual terms by 2. So I've got 2. All right, do we want to try these 4 with neighbors? I know. All right, so what are we thinking for this upper left one? Yes, that f of x equals to 0. So I've got 0 equals. So now I'm actually solving for the x values here. Now, don't move the 5x over to not divide by x, to factor. So 0 equals x times 2x minus 5. So x is going to equal 0, and x is going to equal 5 over 2. The next one, that's the color I wanted to be up there. This one. All right, so for this one, to -2x squared minus 5 times the -2x. This one over here. I'm just plugging in the quantity x plus 1 instead of 2. Now, make sure anytime you see a quantity squared, you FOIL it out. If you haven't had me before, I like using a pundit square to make sure I don't miss anything. So x squared, x, and 1. So this becomes 2 times the quantity x squared plus 2x plus 1 minus 5x minus 5. Distribute that to the 3. Combine your like terms and call it a day. Now, what are we thinking for that right-hand side one? That was weird. Yep, so take your original equation, and then we already found f of 3 earlier. It was just 3. So that would be an off of it. Now, the reason I write it that way is because that is standard form for a polynomial. You want it to go in order of x squared, x constant. So far, so good? Probably, yay, I know this stuff. All right, we've got sum, difference, product, and quotient of functions. You want to take a second and write this 2 down, or 4. All right, we okay with this? Want to actually work with some of them? Nick? We're going to do composition in a couple sections, but we can if you want. So the question was, what about composition? So that's something we did last year. So that is FOG. I know it looks stupid, but X is the same thing as writing F of G of X, and this is composition. All right, so essentially composition, you guys remember, this is what we have, you suck people in and then it comes down. That's kind of what a composition is. All right, so you take whatever G of X is and plug it in every time you see an X in F of X. But we won't really be working on this quite yet. All right, ready to scroll? Okay. So here are our examples. If you want to take a second, write all that fun stuff down. Ready? So when we start with multiplying them, 1 over x plus 2 times x over x minus 1. Can I simplify anything before I begin? Now, when it comes to actually multiplying this, I would just multiply straight across the top, straight across the bottom, but I would not factor everything out on the bottom yet, or pulling it all out. I would leave it just like that. Now, when we do division, you could do this, but I would not necessarily recommend this, so don't write what I'm about. F of x divided by, that's called a complex fraction. That's not very fun to deal with. There's too many lines now. So instead, the easier way to do it is to flip and multiply when you begin. So 1 over x plus 2 times the reciprocal of g of x. All right, so we've got some information on domain that you're going to want to write down. All right. We want to talk about this. We kind of remember it. Domain is really just what x values is the function going to work for. And there's a couple major restrictions that happen with it. You can't take a log of a negative number or a zero. You can't divide by zero. So when we did rational functions last year, anything that made the denominator equal zero became an issue in our domain. And then square roots of negative numbers, yes, they're imaginary numbers, but we don't graph imaginary on the same plane as the real. All right. So we're going to look at these, and we are going to find the domain. Are you ready? Let's go first two. So f of x, what kind of equation is that? Quadratic. So quadratic, kind of looks like this. Are there any restrictions on the domain for a quadratic function? No, not on domain. Every x value you can possibly think of will work. So there's going to be a couple different ways of writing this. You could write it in interval notation. And that's going to be from negative infinity to positive infinity. And remember, we use parentheses on that because you can't hit infinity. It's a constantly moving target. You've got inequality notation, so that's with the little greater than less than signs. But the new one is going to be set builder notation. gotta do the fancy squiggly directions. So look at this. So the way I do it is I start at the top, bring it out that way, and go reverse. Alright? And if you can't do the little squiggly brackets, if you can't make them all pretty like that, it's okay. Because you can just go like this and I'll know what you mean. People are like, I can't draw that. So in set holder notation, the way you read it is it's every x such that line means such that, x is in the real numbers. Okay. Now, if there's no restriction on the x, you could just do squiggly x, squiggly. Every x, you can take that for 1. Okay. For the g of x, am I going to have any possible products? Can I factor out that denominator? Yeah. So the denominator ends up factoring to being x plus 2 and x minus 2. So my two issues are going to be what makes the denominator equal 0, it's positive and negative 2. So if we do it in interval notation, that's going to be negative infinity to negative 2. It stops, does not include it. It goes from negative 2 to positive 2, stops, does not include it. And then 2 to positive infinity. You kind of remember doing that last year? We kind of hated doing it that way last year. So this is where set holder notation comes in and kind of makes our life a little easier. So what you'll do is you'll go squiggly x such that x does not equal positive or negative 2. A little bit easier. All right, do we want to do h of t and k of x? Yeah. So let's start with this one over here. So it's a square root function. My issues are going to be anything that makes the square root equal a negative number, correct? So I always start by trying to figure out what's going to make the underneath part of the square root equals 0. And the reason I do that is because it gives me a starting point, and then I pick a number on the left, pick a number on the right, see which way it's going to end up causing me problems, and then I can write it. So we have 4 over t equals positive 2/3. So to make our lives a little easier, we can pick whole numbers that would work on either side. So a positive number that could work as 1, and then a larger positive number that could work as 2. So do you guys want to check positive 1? And do you guys over here want to check positive 2? And tell me which one's going to give me a negative. And you have to check it under the square root. Yeah, so 4/3 is 1.333 repeating, so I'm going to pick the next whole number on the left, the next whole number on the right, and see which way you can go up.
Substitute.
Yeah. So that 2 is going to be the problem. So anything greater than 4/3 is going to start getting negative. I can't take square roots of negative. It's not going to be anything. So do we just want to write this one in step builder? I feel like we're starting to like step builder a little bit more. So step builder x such that x is less than or equal to 4/3. What are we thinking for the last one? Is there definitely something that you know is out of the domain? Yep, 5 is definitely out of the domain because it's going to make the denominator 0. We can't cut it by 0. That is out. So I know that's out. Squigglies x such that x does not equal 5. But I've also got to look at the numerator of this because I have a square root in the numerator. I can't have any imaginary numbers. So we're doing exactly what we did on that last one. 3x plus 12 equals 0. X equals to -4. So a number on the right of a number line would be -3. And on the left, 3.5. Which one's going to cause the problem? -3 or -5? 5. All right. So when I go to plug -5 back in, I've got -15 plus 12, and that is the negative, and that makes me sad. So that's also out of my domain. So x can't equal 5, and this is my little symbol for and, by the way. Just because I can't do the other squiggly without having to come out, it's hard. So I'm looking for every x less than -4. Okay. Now, should this one end or equal to? Because if I do equal to, is that okay? Can I take the square root of 0? Yeah, square root of 0 is just 0. So I don't need it. Let's get rid of that. We don't need it. It's just everything less than.
And this is the difference quotient, which we may not have enough time to get to all of it, but if you just want to write this part down,
I will end up finishing this recording and putting it on Google Classroom, and then you guys can write all the work down. Forgot these first couple days are questions. So remember, with that difference quotient, essentially what you're doing is you are going through and you're going to plug in f of x plus 8, and then you're going to subtract off your original equation, and you're going to divide the whole stupid thing by 8. Okay, this is an introductory thing to calculus. I know that's scary, but you're going to be fine. So the first part I've got to find, and get this thing to stop moving, is f of x plus 8. So what I tend to do is I tend to find them in parts, put it all together, simplify as much as I can. So I'm plugging in x plus h, so 2 x plus h, quantity squared. And then what happens with this is I have to go through and FOIL everything out. So I've got 2. All right. I'm going to simplify that monster down as much as I possibly can. So 2x squared plus 4. Alright, I'm going to finish recording this in between passive periods and I'll upload the video. You'll only have about 2 minutes at the end that you're going to want to watch. So just to finish that. Yes, you do have homework tonight because my work is stupid. I uploaded the actual minute from the book. So for you, it's not due until the 28th, so don't feel like you're not going to finish it. Okay. So. I've already done any part, and I got it. I'm gonna go minus my original equation. So 2x squared plus 3x. You distribute it. And then all of this is divided by 8, so I'm actually going to show that. So this and this go away, this go away. So I'm left with 4x plus 2 and remember that is multiplied by 1. So